Hello guys, this is Engineer Leo Ramos of College of Engineering and Computer Technology of Wesleyan University-Philippines. Today, we're going to discuss a series of communication systems, laboratories, and experiments. Hello guys, Engineer Leo once again, and today we're going to have a laboratory series for communication system. For this topic, we're going to perform different line encoding techniques. For this laboratory, we're going to perform different line encoding technique, and line encoding technique performs different functions in signal transmission. We do have now the Manchester, the bipolar, the NRZ-30, and other line techniques. To perform this laboratory, we need to utilize different modules and different equipments. So we do have here a digital oscilloscope, and it must be the pre-calibrated one. And we're going to use our Di Lorenzo digital signal transmission modules, or the DL3155M62. Also, we're going to utilize our auxiliary module, our DL3155M62A. To start with, we need to connect our Di Lorenzo trainer, the module M62, to our auxiliary modules here, because our auxiliary module doesn't have an external power supply. So we're going to use the internal power supply of this module via this particular jumper cable. Also, we need to secure our oscilloscope with our three oscilloscope probe for channel 1, for channel 2, and for external triggering. To do that, let us connect our jumper cable with our negative 15 ground source. So I can connect on this option or via this one. So these two are already connected. So I can have here the 15 volts. I can have here the negative 15 volts and our ground. Then we're going to connect this into our modules, the auxiliary modules, for positive 15 volts, for negative 15 volts, and our ground. So that is how you do the to power up the external modules. Okay, and for the oscilloscope, we need to have also a different jumper cable connecting our TX clock here. Okay, so the TX clock here must be connected on the clock of our Di Lorenzo trainer here. Okay, and our TX data, which is on this portion, be connected onto the Di Lorenzo input data. Okay, our oscilloscope probe from the external triggering, we're going to connect this into the trigger slot in this way, and make sure it is grounded on the auxiliary modules. Okay, our channel 1 of the oscilloscope will be connected either from this one, the data here, or the data in this portion. So let's say I can connect the oscilloscope under this data, and it should be grounded also. And for our output, we can put this into this port. So this is our RZ, means return to 0. NRZ, that is non-return to 0. We have here the Manchester coding. We have here the biphase coding. We have here the D binary or duo binary and our duo phase shift keying. So we will show the different waveforms of different line encoding techniques. So I can have the oscilloscope probe to be grounded, and I can select output of different line encoding techniques. Okay, I can select here our first line encoding, which is the return to 0. And that is how you connect our laboratory. Okay, let's verify and view the different waveforms of our different line encoding technique. To do that, let's power on our power on button on the DiLorenzo modules. Okay, as you can see, that is our signal waveform. Just press the auto set button of the oscilloscope. So that is our first line encoding technique, that is the return to 0. So on the channel 1, we have here the data coming from our auxiliary modules, and channel 2 will be our output, which is the return to 0 line encoding waveforms. So under our auxiliary, we could set this up to a clock rate of only 2400 Hertz so that we can visualize it, and we could use our word length to 15 bits or 16 minus 1 bit. Okay, to appreciate the waveform, let us press the run stop button. Okay, so that is our return to 0 waveform. As you can see here, so this is equivalent to a 1 logic 1 from here up to this one. So since this is a return to 0, the logic 1 will be returned to our reference axis here. So every time that there is a logic 1 that is being present at the input, so it will be returned back to 0, logic 1, and the logic 0 will be as this one. So there is some kind of delay. So actually, this waveform is up to this one. Okay, so that we can have an accurate data waveform on the return to 0 modules. Okay, so that is our return to 0. Wow. So let's have another kinds of line encoding technique, which is the non-return to 0. So I could change our channel 2 probe of the oscilloscope into a non-return to 0 port in the DiLorenzo. So that is our waveform for a non-return to 0. So let's appreciate the waveform by pressing the run stop. Okay, when you say non-return to 0, actually for non-return to 0, if the original signal is this one, or original data is like this one, so the output waveform will be just copy the original input. So actually there is a delay here. So if we could push this signal up to this portion, so this logic 0 here will be this one, this logic 1 here will be this portion. So for a line encoding technique that is equals to non-return to 0, so the input data will be our output data.
Amazing!
Okay. And another options, we will have here the Manchester. So this is the waveform for Manchester. So again, to appreciate, just press the run stop. And that is the waveform for our Manchester. So for Manchester, having a data of 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, etc. So we can have this waveform. Wow. And also we have our waveform for a biphase. Okay, a biphase is this waveform. So for a biphase, if there is a logic 0, so the waveform will be goes like this. And if there is a logic 1, like this one, so we could have this Z, so the inverted Z. So if this will be our for logic 0, so the inverted Z will be the for logic 1. So that is the biphase.
Oh my God!
And we have here our duo binary waveform. That is the duo binary. So we could press the run stop to appreciate the waveform. And there you go. So you have here different levels of binary signals, levels for every logic data, 1 and 0. So we have here different levels of waveforms.
Wow!
And lastly, we have here the BPSK or the DPSK or the duo phase shift keying. So let's try to put it on the proper port, and to appreciate, just press the run stop. So that will be your DPSK waveform. Okay, so that's all for today, and that is the line encoding technique. For the next laboratory, so we'll proceed to a line decoding technique. For more videos regarding communication system, please like, share, and subscribe this channel.